In this lecture, we have to discuss the second segment of the course. In the lecture number one, we were discussing about how to handle the data in R, and we have to discuss later on that what are the steps in data cleaning was the lecture number two. So here we have to start the models. The first model that we are discussing is the linear model. Is a It has the many forms. It may be the models which has two predictor. It may be a model have multiple predictors. It may be the linear in nature. It may be non-linear in nature. Then we have to collect the data from the social media sites like Twitter, Facebook, or Instagram. We have to get the data from these uh, different social media sites, and we can apply the model for analyzing such data. Then we have to discuss association rule. Association rule will gives us the opportunity to set some items which are highly related to each other. Suppose customer buy milk. So what is the probability that the customer will also buy the butter and the bread? So this type of association can be determined by, and this is helpful in organizing the things in a departmental store. Then we have to discuss the nearest neighbor classification trees. It has several forms, but then we have regression trees, text mining, and clustering. So these models are categorized under two major segments. One of them is called supervised learning model and unsupervised learning model. So we will discuss the detail later on, but today we have to start by introducing the linear model. A linear model is based on several predictors. If we have two predictors, if we have one predictor age and one response y. So in this data we have the two variable. One variable is called uh, predictor is age. Age is predictor, and response is price. Response means predicting, or the dependent variable. It is the predicting. And we have to find out the strength of the relationship. This is called correlation. So initially we start by correlation between x and y and by applying a function. So the range of correlation is what, from -1 to +1, and with the equal to sign. And if it is strong in nature, then we can build a model which will gives us a better predictions. If the strength of correlation is weak, scatter plot is indicating a high scatter like this. We have a very high scatter. If the scatter is very high, then the accuracy of the prediction will not be as good as we are expecting. So strength of relationship is a very important thing. Then we can construct this scatter plot. If the scatter plot has a closely bounded points on the best fit line, then we can say that the model will be the good model. Otherwise, if the points are away from this line, then we have a weak relationship. If we have a weak relationship, then such type of model will not give us an accurate prediction, and the accuracy of the predictions will not be as we are expecting. The dependent variable should be taken on the y-axis, and dependent variable on the x-axis. Predictors are predictor maybe one or maybe more than one. the dependent variable will be one dependent variable, the one class variable we should have. So we can build the model by several predictors, whereas we are expecting in this data, we can introduce the more predictor like the condition of car or other things as well. Now, different scatter plot is shown into this slide. This is a perfect positive correlation. This is also a perfect positive correlation. This is exponential with the high degree of association because the points are very close to this exponential model and the points are very close to these line, but this is linear model, this is non-linear model. These two are indicating a strong relationship because the points are very close to the line. This is also a very strong relationship, but this is non-linear in nature. We can call it as a quadratic model we have. This is a special graph. This is indicating that no relationship means the variable are independent. This variable y is not associated with x, y is independent to x means if we have this situation, model is a poor model. We cannot construct the model in this situation. Means y is not helpful. Sorry, x is not helpful to predict y. This is indicating what? This is indicating that x is not influential on y. X is independent of y, so we cannot build the model. So this is not the good situation for a linear model, but very good situation for the linear model. This is a very good situation for a non-linear model and exponential model. Perfect situation if it is such model is called deterministic model. So this is not random model. This is called deterministic model. The deterministic model is used in basic sciences or in natural sciences. But whatever model we are using in real life, like business environment or the business scenarios, we can apply the probabilistic models. These models are called probabilistic model. Probabilistic model or stochastic model. Now this is a one predictor linear model. In this model, we have beta naught, beta 1, x. X is a predictor. X is a predictor of the independent variable. It is called predictor or independent IV. I will generally use the term IV for it, independent variable. And y is the dependent variable. It is also known as a class variable. In machine learning, this type of variable is called class variable. And we are interested to predict it by using the predictor. The predictor, if there is strong relationship between the response variable and the predictor variables, then model will give us a better predictions. This is the random term or the error term. This is the only random part into the model, random component. So what is the random component indicating? If the points are exactly on the line, if the points are exactly on the line, the model, there is no error. But if some points are away from the line, we have a strength of error. So that as much error we have, the points are away. If the points are too away, means we have a high degree of error. If the points are very close to the line, we have a very small amount of error in the model. This is regression coefficients. These are called regression coefficients. Regression coefficients are what? Regression coefficients are the weights. These are called weights. Weights means if we have a strength in weights, means beta 1, if beta 1, the value of beta 1 is very high, means this variable is a very high strong related with the y. And if we have a weight of the other predictor is very high, that means that these predictors are very helpful for us. The weights are basically the weightage to this predictor. In this model, we have only one predictor. If we have a more than one predictor, then every beta means the slope. Every slope is indicating a weight. So the as higher weight we have means the importance of that predictor in the model. If the smaller value of weight indicating that small degree of dependence of y on x. So this is very important. The weights we have, our objective is to learn the model learning. All of you are familiar with the learning the model. So learning the model means what? Learning the model means we have to find out these weights, betas. We have to find out these betas. So find out, instead of using the term find out, we use the term estimates, because we have a sample data. The estimates, we have to estimate these betas. This process is called learning the model, right? So what are the steps in modeling? All of you are familiar in the, you have to first define the research problem, what your research problem is. Second thing, you have to collect the data related with that, collect data for that problem. What predictors should be included into the model? What will be the response variable? So these types of decisions has to be taken after describing the research problem. Then step number 3 related to the data cleaning. You have to check whether there are NAs in the model data, or there are missing numbers. Or then after cleaning the data, we have to break the data into 2 segments. Break data into 2 parts. Testing and training. Training data plus testing data. So this is just a random sample of 80-20 or 70-30. So training data comprised on 70% observations, and then testing data comprised on 30% observation, or your user can change it. Then training part will be used to build the model. Training part, training data will be used to learn model. So this is called model learning. So this is a very important step. So what we are doing in the model learning, we are basically estimating betas. Estimating betas. This is important thing. Then in step number 6, we have to test the model, test the accuracy of the model. And if it is good, to deploy the model. And if it is not good, so you have to repeat any of the step from the previous point. We may have to re-clean the data. We may have to distribution of the training testing. We can change that. And the very important thing which we generally follow is to propose the model. One thing is missing in between that 4.5 model propose the model. Which model is propose the model? This step I was lacking. So most of the time we follow the model proposition repeatedly. Then another model is applied and then tested. If it is not accurate, then another model is used. So this is the iterative procedures. Okay. So now come to the point. These points are called the observed points, and this point is known as estimated point. This is given by the model, and this is in the observations or actual data. So these points are my actual data, and the best fitted line is there. The difference between these two is called error. So this is one error, this is another error, this is another error. These values are called errors. So our objective is to minimize the error. Minimize error. Minimization is a very important task, and we have to think on that, right? So these are the assumptions. Relationship should be straight and strong. Relationship between x and y is straight. Straight means the linear, and strong means points are very close to each other. So if as strong we have the relationship, we have an accurate model. As weak relationship we cannot build the model, or the model will not give us accurate information or accurate prediction. Independent variable is assumed to be fixed, while the values of y the randomness in the values of y comes from the error. So this error will gives us a deviations from the line. Sometime it is above the line, sometime it is below the line. So that is a reason for the error. So if all the points are on the line, means there is no error. If the points are moving up and down to the line, we can say that if there is a high distances, the high amount of error. The low distances, points are close to the line, so we can call it as a small amount of error. The variance in y at every point of x is same. Variances should be same, means variation in x and the variation in y should be stable. That is called homogeneity of variances or homoscedasticity. And error term is random. Error term should be normally distributed. The mean of error should be 0. That is one of the very important assumptions. Then that is mean of the error is 0. Means what? This is the negative value of error. This is the positive value of error. This is positive. This is positive. If I sum of negative values of error and positive values of error, then total will be 0. Total of error will be 0. That is why the mean of error will be 0. Mean of error is 0. So this is an important assumption. Now we have to find the beta naught. Estimate of beta naught is the B naught, and estimate of beta 1 is B1. So this is y-intercept in the model. And this is slope. Slope intercept. So we can have idea of slope intercept form of the model. And this is the same model, except only the error term we have. And this model is called estimated model. So we should have to place a cap on the left side if it is a estimated. Whenever I place a cap, error will be minimized. If I remove the cap, then there will be the error. If I place a cap, then error will be zero. Why error will be zero? Because caps come after taking mean, and the mean of error becomes zero. So this is called estimated model. This is called estimated model, and this is known as observed model. This is observed model because error is there, and error is minimized. That is why we do not have. This is called estimated model. So we have to find out the betas. Betas can be determined by the method of least square. You have to differentiate with respect to the first parameter. You have to differentiate with respect to the second parameter, and then optimization is used. Optimization means you have to find out the betas in such a way that the error should be minimum. Error sum of a square should be minimum. So this tool is used for estimating the model. So these two equations were obtained, and after solving these two equations, we will get the value of beta naught and beta 1. So how the software will gives us the b naught and b1. So this is the equation, and this is the equation which model will use. So after solving these two equations simultaneously, the software will gives us the value of beta naught and the beta 1. This is not too difficult. It is just a simple. So what is sigma y? Sigma y is the total of the variable y. Sigma x is the total of the variable x. N is the number of observations. So only two things are unknown. One is beta naught, other is beta 1. Summation xy is a one column total. This is summation x. This is summation x square. So we have these equations. These equations can be solved simultaneously to get the value of beta naught and beta 1. So this is the technique which software generally used to find out the values of beta naught and beta 1. So I will implement this model into R and will show you how uh, these beta naught and beta 1 are estimated. The summation of these will be calculated. This is summation xy, this is summation x square, summation y, summation x. If I put all of these total into these two equations and solve these two equations simultaneously, we will get the value of beta naught and beta 1. So beta 1 will comes to the minus 20.26, and beta naught will comes to the 195.47. So if you have these two values, then we have a estimated model. So this is the estimated model. This is the estimated model. This is the estimate of beta naught. This is the estimate of beta 1. We call it as a slope. We call it as an intercept. This is indicating what? Minus 20.26. So you should have an interpretation of this model, because we are not going to solve model manually. We will do it by the software R. The values of 20.26 and the value of 195.47, 20.26 with the minus sign indicating that every year the price will be decreased by $2,026 every year. If the X is 1, means 1 year old car, the price will be decreased by $2,026. If it is a 2 year old car, then $4,052 will be reduced. If it is a 3 year car, then 6,000 and something dollars will be reduced. So every year, $2,026 will be reduced. And this is what? This is y-intercept. Y-intercept is indicating this point. This is y-intercept. 195.47. It means if the value of x is 0, then it means 0x. 0x means it is a new car. If it is a new car, then the price will be $19,547. So this is a y-intercept in the model. So all of you should have a familiar with the concept of slope intercept in your calculus, but we are using these two here. Now I am going to implement this model into into R, and we'll show you how this model will be implemented in R. Now we are going
Yes, sir.
to implement a linear model, and the same data set I am using is a price data and the age data. So we have to create the two vectors. One is the vector of price, and you can see that to combining these observation, we have to use C. C is used for combining these observations. So a vector will be formed. Another vector is formed age, but I'm not going to construct a data frame, because if I join price and age into the one collection, that collection in R is referred to as data frame. So I'm not going to make a data frame. Two isolated vectors I have. One vector is the price vector, other vector is age. When I run these two commands, then in our session, in our memory, two vectors will be created. Then another command I have, this is a very important command. And you can see that LM, this LM, I'm writing this by my pen, how to build the model in R is the one of the important thing. LM stands for the linear model. In the small letter you have to write. So this is a command. LM is a command. And you have to define the dependent variable and a symbol of tilde, this symbol. And you have to use your independent variable, which is age in this example. The dependent variable in my model is dependent variable is price of car, and independent variable is age of car. If I have more than one independent variable, then the procedure will be what? Procedure will be LM dependent variable, this symbol, predictor 1 plus predictor 2 plus so on plus and close bracket. So this is the line which we will use for applying several predictor model, and this is the line which we will use for a single predictor model. So here you can see that acha, on the left side you may have a blank, means nothing should be there, but you can name this model. I name this model as LN model, LN for the linear, not logarithm. It is the linear model. It is the user defined word. Any name you can give to this model. So I used LNMOD. LNMOD representing the name of this model. After implementing the model, I assign the results to the LNMOD. So what next line is doing is showing the results. Because if you write down the variable name in R, then the result of that variable will be shown in the console. Then we have two graphs are printed or plotted. One is the fitted versus residuals. X-axis contains the fitted values and y-axis contains the residual values. And another plot is called QQ norm. It is a probability plot. Probability plot, for what purpose the probability plot is used? Probability plot is used for testing normality. Testing normality. Why the normality is needed? Because I told you the error should be normally distributed. So this is the check. QQ norm will do what? It will plot the residual graph. If this residual graph is linear in nature, we can say that the yes error are normally distributed. If this probability plot is not linear in nature, is an indication of violation of normality. So your data should be normally distributed. That is one of the important aspect of this model. Now I am going to run the model and will show you the results. ये मैंने पॉज रिकॉर्डिंग कर दी है और अनोटेशन डिसेबल कर देता हूँ क्योंकि किसी को शरारत भी सूझ रही है बीच बीच में। ये देखिए अभी आप इतने सीनियर लेवल पे आ गए हैं और लेकिन एटीट्यूड आपका ये है। चलिए मैंने अनोटेशन डिसेबल कर दी है। अच्छा, इसमें आपको कोई चीज़ समझ नहीं आ रही है तो पूछ लें आप। ये इन 4-5 लाइनों में मैं फिर रन करूँगा इसको।
सर रिकॉर्डिंग ऑफ नहीं हुई
आपकी
है।
रिकॉर्डिंग ऑन है।
अभी भी ऑन है। अच्छा, now we are going to execute this model line by line. I'm going to execute line number 1, click on line number 1 and press the run button. So you can see that the vector of price is created. Then line number 2, the vector of age is created. In the memory now we have the two variables. One is this is the age variable, and next variable is the price variable. This is the price variable. So we have these two variables created by just execution. Next line is implementing the linear model. Linear model is created and stored into the ln mod variable. Now another variable is created here, ln mod. Ln mod is what? Ln mod is a model variable. Ln mod. You can see the ln mod here. Ln mod is a variable, is a list of 12 values. So what values are there? Next line will show these values here on the bottom of the line. Now these are the values. You can see I'm just going to show it what this is the result of the model. The model is call lm formula price age. Price age. Price is a dependent variable. Age is this is showing in the result that what the model is. The model is basically a linear model with one predictor. Age is the predictor and price is the dependent variable. Now you have the exactly same values that I shown in the slides. Age, this is beta 1, this is beta naught, this is your intercept. So what will be the model? You can write down the model here by these two values. The model will be price is equal to 195.47 minus 20.26 age times age. This is called predicted model. This is called predicted model. Now you can check the accuracy of the model. The two lines are to be executed, which shows the graph of error and which shows the other outputs. The next line is the plot command. Plot command, when I execute the plot command, fitted versus residual. So the fitted values, which are the values of y cap, and these are the residual values. Residual values means these are the error values, and indicating what? Indicating that we have a scatter. Because we have a small sample size, the few values are indicating, but actually this graph I shown on my presentation, that should be the random points on this line. Random points on the graph is indicating that the error is random. And the next line is the QQ norm, which represent the normal priority plot. So you can see the normal priority plot. The points should be linear in nature. As the points are linear, we can call it as a good model. Means the error are normally distributed. Linear line indicating what? Linear line in this graph is indicating that the error are normally distributed. Error follow a normal distribution. And the mean of error will be 0. And the variance of error should be indicated by sigma square. So these are the assumptions for the linear model. And you can see the result of this model here in this output. Now, one student is asking about the interpretation of the two regression coefficients. So this is called regression coefficient. 195.47 is the intercept and 20.26 is the slope. Slope intercept form. Slope is indicating that
Your screen is not showing far.
what is the what is the value of price depending on age. So this is indicating that minus 20.26 multiplied by 100. Why multiply by 100? Because the data was given in terms of 100. The first price is not 85. The first price is 8500. The next price is, last price is $4,800. So it means the data is hundreds of dollars. If I multiply 20.26 by 100, so it will have 2026 rupees. Acha, now what this 2026 rupees is indicating? This is indicating that by 2026 multiply by age in the model. Age is 1 year. Suppose the age is 1 year. Every year 2026 will be decline in the price. As car becomes old year by year, each year there will be a decrement or the depreciation in the value of car. What the depreciation is $2026 every year. If it is a 2-year-old car, then the how much will be the depreciation? Multiply by 2. If the car is 3-year-old, the depreciation will be how much? 3 multiplied by 2. And what is the actual value of car? This is your brand new car, because if in the model we are placing, this is y-intercept. This is y-intercept. 195. This is 195, 195 or 19547. If it is a 0-meter car, then its price will be this. If you purchase the car and sold out, what price you will get? 19547 price you will get. If 1-year-old car you sold, then price be reduced, so you will have a decline in price. How much price will be declined? 2026. If a 2-year-old car is sold, so you have a decline in 2026 multiplied by 2. So year by year it is going down. Year by year the price becoming down. So this is an indication that how the price is decreases. So this is called slope. This is slope. And all of you are familiar that the slope is what? Slope is indicating that change in y with respect to 1 unit change in x. This is the actual definition of slope. Change in y. How much change will occur in the variable y if we change 1 unit in the variable x? If the age becomes 1 year old, then the price will be $2026 will be the price reduced. The reduced price by 2020. That is the meaning of the slope and intercept into this model.